What's up, math scholars? I'm going to make a short video on how to do the math problems in the logarithm project because I've got a couple people at home on quarantine and they're doing the project all by themselves. If you are in class, you can work with 2 to 3 other people. So just an intro, the measurements of earthquakes are logarithmic. So it's a logarithmic scale. And what that means, if your earthquake, oops, I wanted to get a pen. If your earthquake measures like a 2 on the logarithmic scale, and another earthquake measures 4 on a logarithmic scale, they're 2 apart on the scale, but they're 10 to the second power apart with intensity. So the 4 earthquake is 100 times more intense than the 2 earthquake. So today you're going to be talking or reading about me. I felt an earthquake that measured 5.1 on the scale. And maybe you're going to be studying an earthquake that measures 8.7. To figure out the difference in intensity, you'll do 8.7 minus 5.1, which is 3.6, and then you'll do 10 to the 3.6 power to figure out how much more intense yours is. So yours is actually 3,981 times more intense than mine. This is the formula that you're going to see on your project sheet. It's the formula they use to solve for moment magnitude. What they'll do is they'll plug in the seismic motion in for MO, and that's normally a huge number in scientific notation. It's measured in Newton meters, and they'll calculate it out, and then they'll get their moment magnitude. Now, you might have heard of the Richter scale before. I'm not even really sure how to spell it. Richter scale. There might be an extra T. They don't really use the Richter scale anymore. They now use the moment magnitude scale, but it's pretty much equivalent. All right, find the moment magnitude of the San Francisco earthquake in 1906 that had seismic motion of 9.01 times 10 to the 20th Newton meters. So that's going to be going in for MO. I'm going to type it into my calculator for you guys so you can kind of see where the parentheses will need to end and things like that. So you'll go 2/3 first. I put my parentheses around the 2/3 just to be safe. I tend to always use parentheses. And then here's where my 9.0157 times 10 to the 20th will go. I'll have to close that parentheses off before subtracting the 6.07. And so this San Francisco earthquake is 7.9 on the moment magnitude scale. 7.9 moment magnitude, MW we can call it. That's a very famous earthquake. It shook the whole city. Most of the buildings fell down, and then the city caught on fire, and almost the whole entire city burnt down. I read a book about it. All right, let's talk about a little less famous of an earthquake that hit Sweden. They don't get very many earthquakes. It had a moment magnitude of 4.1. So this time we have the moment magnitude provided, but we're going to be solving for the seismic motion, MO. Right? It's a little different. We're going to use a solving technique. It's not hard to do at all. Our first step is going to be to add the 6.07 to the other side. And that's going to be 10.17. The next thing we're going to do is try to get rid of the 2/3. So to get rid of the 2/3, I'm going to multiply by 3/2 on both sides. Now this is a base 10, so I'm just going to put that there to help us on our final step. 10.17 times 3/2 is 15.255. Now to finish this off, we're simply going to put it into exponential form. We've been doing that in class. So it will be 10 as the base, the 15.255 as the exponent, and it's going to be a big answer because our seismic motion is normally a pretty big answer in scientific notation. So here it goes. My calculator is reading 1.79887, capital E 15. What that capital E means is it's in scientific notation. I'm going to round it. So I'm going to round it to 1.8 times 10 to the 15. But that is your seismic motion. The label for seismic motion is Newton meters. So that is how you will solve a problem when you're given the moment magnitude and you need to find the seismic motion. And finally, one earthquake has moment magnitude of 4.1. If another earthquake is 900 times more intense, what is its moment magnitude? So this one is a little different. What we're going to do is we know it's 900 more times intense. So we're going to set 10 to a certain power equal to 900. To solve this, I'll put it into logarithmic form. Since I have a base 10, I can use my regular log button. My exponent would go over here, x, and my answer would go here, 900. And to type it in, it's going to be easy. You can use your regular log key. Log 900. It's 2.95. So what that means is this earthquake is 2.95 moment magnitudes away on the logarithmic scale. So you'll just add them up. 4.1 plus 2.95 is 7.05. So an earthquake that is 900 times more intense than a 4.1 is a 2.95. Okay. Or is a 7.09. I said that wrong, but 7.05. All right, so now you can have fun working on your project. Basically, if you are at home working alone, you just kind of tell the story about if you've ever felt an earthquake, and then you just do a bunch of calculations. At the very end, you get to research your own earthquake. You just research any famous earthquake you want, do some calculations about it, and then your probably best bet if you're at home is to do a Google slide, and there's a submission tab in Polaris for the Google slides. Okay, have fun.